and you're going to return up here, and then have your phone out and upside down. Okay, so yesterday, kiddos, we went ahead and started this motion problem. However, did we finish it? Yes or no? What did we answer? Part A, because that's the position function. X of t. Okay, but what haven't we done? I want you guys to really quickly, in your new groups, be like, what are the words saying? What am I supposed to do in order to accomplish that task? What are the words saying, and what am I supposed to do? Go. Thanks for the reminder, Nick. You just put it on my desk when you're done. How'd you guys do? Does that make sense? When, find t. When, find t. Is 0. Oh, sweet. So all we have to do down here is set homeboy equal to 0, right? So we have our position function. We already solved that yesterday with integration. Integration going back twice from gravity. There are formulas if the gravity is constant, or I should say if the acceleration is constant. There are formulas you could plug straight into. That's totally true. Or you could be aware that sometimes the acceleration will not be a constant, and you actually have to use the integral. It's up to you. Either way, you're practicing the concepts. But why are some of you right now like, ugh, really? What are you supposed to be doing? Finding t. Now, this is on a calculator portion. What would you guys do right now? Remember we looked at that sample AP at the beginning of the semester and said that there are calculator problems where you need to use your calculator to make things go quicker and more efficiently. How could you use your calculator if this was on a calculator portion? You could graph that and look for the zeros, right? Is there anything hinting for us in the problem like what our window range should be? Like if this is going to happen in 5 seconds, 10 seconds, 100 seconds, like anything that gives us any clue? I don't see anything. I don't see anything. So since there's nothing that's going to specifically help us, then I would probably just throw it in your Y1 and then look and see if you see an intersection. If not, start zooming out. That's what I would probably do. But what if it was on a non-calculator portion? It tells you you have to do something by hand. Now, Patricia's like factoring, but some of you are like, A times C, negative 16 times 80? Heck no. Hold on. They're all even. Yeah. Who's figured out something to pull out? 16? 16 goes into that one 4 times. It goes into that one 5 times. Heck yeah. Pull that negative 16 out. T squared minus, I'm pulling the negative out because who likes the negative in the A term? Ugh. What do we got? 4t minus 5? This would not be on a calculator portion of the exam because can't you just do t minus 5 and t plus 1? My zeros are negative and 5. You guys should know. Which one am I going to answer with, though? Starting at t equals 0. The ball is thrown at t, so negative 1 is not even a part of the situation. The ball was just chilling in the person's hand at that point. Does that make sense, guys? Are you going to maybe have to look back at that forever card just a little bit where we talked about some of the terminologies? Like average rate, instantaneous rate, maybe round, maybe. What else? Got it yesterday. You might need to look back at that card just for some of the wording, but you guys did a great job on that when you discussed. If you guys look at the top of this, I don't know how many of you guys actually started homework. From what I could tell in 0 period, barely anybody. And that's okay. That's okay. You're just going to have to work a little harder on calc tonight. You guys know if it's like an easy calc night, you better do your other homework, because probably the next night will be a harder calc night. But in these ones in your book, just a quick warning, they're not going to necessarily for every single problem say, hey, what? Or, hey, guess what? Acceleration is negative gravity. Hey, guess what? Acceleration is negative gravity. It's going to be like in a little paragraph, directions above like 15-word problems. But for right now, acceleration is negative 30 per second squared. That's one form. It could also be negative 9.8. I have never seen the AP require you to have that memorized, though, which is why we're not putting it on the forever card. But in our homework, you are going to have to kind of come up with it, even though it's stated right up above in directions. The next problem is a bit more intense, so let me let you guys have one more chance to work together and kind of powwow a little bit. And the next problem we'll work through all together as a class. Set, go. What can you plug in and where? Are you as a group going to be plugging straight into formulas because they apply, or are you going to be integrating to get there? Either way works. I don't know about you guys. I see something with a velocity and something with a position. With what initial velocity must an object be thrown upward from ground level to reach the top of the Washington Monument, the height of approximately? Why aren't you guys talking? You can look at your notes, you can look at the formulas. Turn around, talk, talk, talk. AJ, just pop over for today. It's okay. What's the extra I added in that you guys might not have seen? We have a constant acceleration from ground level. We have a height we need to get. What's the last thing? Why am I saying that? I'm going for the bare minimum, and the bare minimum would be maximizes at 5. Maximizes. What's true there? There's a momentary, it changes direction, and if velocity changes direction, it changes sign, and if velocity changes sign, what happens in between? Or you can think of horizontal tangent line, kind of. Yeah. So I said, oh, if 555 is my max, then I know that the derivative is 0 there. Critical numbers. Or velocity changing signs. I have a lot of stuff. Who's going to stay unknown the whole time until the end? That guy. So what happens when we integrate acceleration? We get velocity and we end up with, anybody get negative 32 t plus our unknown? Then you could integrate again. And 1/2 times 32, t squared. You would end up with negative 16 t squared plus our unknown plus our initial position, which is just 0. But maybe what you didn't realize is how do we solve when we don't know t or v sub naught? But we know that when position is 555, what's velocity? 0. Now what do I have? Starts with an S and ends with an istem of equations. I have 2 equations with 2 unknowns. Are we supposed to be able to do that in math? Yeah, we are. Why does it seem to make sense that I'm going to solve for t by subtracting v sub naught and dividing by negative 32, which would end up with a positive v sub naught over 32? Why am I solving for t? And who do I want to be solving for anyway? I want him to stick around. Now is it going to be possible? And the answer is, yeah, it is. Because now I have my 555, my negative 16 times v sub naught over 32 squared v sub naught times v sub naught all over 32. I'm going to pull out because I see, well, this one has 32 squared, but I can pull out 1 over 32. Actually, I can pull out a negative 1 over 32. Let's see what's left. The negative's gone. I'm just trying to make my life a little bit easier. The negative's gone. I have a 16 over another 32, so that's going to be 1/2 v sub naught squared plus v sub naught squared. Oh, wait, this is possible. Okay. I can multiply this side by 32, so that's negative 555 times 32 equals 1 plus 1/2 is 3/2, right? 3/2 v sub naught squared. I can multiply by 2/3. Does 3 go into anything? Ugh. I think this is a nasty calculator question. Who has one close, including your phone? All you need to do for me is go ahead and square root. Wait a minute, square root? Oh, it's minus. I pulled out a negative. Lo siento. Silly algebra. That makes more sense. My bad. Sorry, guys. It'd be 1/2 minus 1, which is negative 1/2. Times a negative 2. And then times a negative 2. There we go. Otherwise, it was going to be square root of a negative. I knew I had done something wrong. I factored out a negative up here, and I didn't put a minus. Struggle. It's the algebra that kills. So I end up with 2 times 555 times 32. I guess we could start breaking that down to be 5, and then 111, and then 2 to the power of 16.5 to the power of 6. I don't think that's a nice square root. Anybody have a decimal for me? 468? Perfect. Yeah, that's definitely a calculator problem. Does anybody have units for me? Is it feet per second? Yeah, because we're dealing with feet and then per second. Got it. Why was this one nasty? There's a lot of steps. I was thinking the nastiness is right here, because you had to think about 555, make him a maximum so you know the velocity there. That was weird. You had to like kind of make that up, but make it make sense so the ball goes up and then it's positive velocity 0, negative velocity, make the maximum 555. Otherwise it's kind of impossible. We can say if if v sub naught is greater than or equal, the ball will at least hit 555. That was, and then wasn't just the math hard? Because what did you have to deal with? 2 equations with 2 unknowns. So you had to do some substitution. So the math was hard, but then also the last clue was hard. Could you possibly see a system of equations in yours? Yep. Will you be able to handle it? I hope so. This one's a little bit nastier, and there's an A, B, C, so we're going to work on it all together. You guys don't have to come up with it on your own. So here we go. What do we got? Projectile is launched vertically upward from ground level with an initial velocity of 33 meters per second. Pause before we go any further. What do we know? Acceleration is constant. Good. And they're telling us negative 9.8. I think I told you that because meters per second is the unit that they're using. We know acceleration is constant. Good. What else do we know? Initial velocity, because they stated it literally for us. Is it positive or negative? Because it's being launched upwards. Every now and then something is thrown downwards, which would give it a negative initial velocity. But what's the last clue we know? Ground level. Good. So initial position is nice. Starts, goes, theoretically is coming back down. Johnson came over Christmas break. Actually, he was on break a little bit earlier than we were, senior last year at Embry-Riddle. He's in this rocketry club. They're doing like crazy things, and legally you're only allowed to have a certain size engine, and he's building his way up, and you have to have different classifications and all this crazy stuff. He was talking about how they were trying to figure out where the rockets were going to land because they're trying to shoot them up and make sure that the rocket maintains its integrity and all this sort of stuff. Anyway, it's kind of a practical application. Not that he said that they were doing calculus per se, but trying to think of how fast is it going, and then they have to think about different things like wind speed, etc. Otherwise, they could be walking around for miles trying to figure out where this thing went. But anyway, coming back. Projectile launched up. Gravity's going to pull it back down eventually, even if it just goes off to where you can't even see it anymore. Find the velocity. Oh, but we don't have velocity. How do we get it? Memorize a physics formula or just integrate, yeah. And what's the integral of negative 9.8 as a constant? Negative 9.8 t plus, who's my c? Does that make sense? Just the integral of constant acceleration using my initial velocity as my plus c. So all we have to do is go ahead and plug in the letter A. V of 3 is equal to, and V of 5 is equal to negative 9.8 times 3 plus 33 meters per second. You're welcome. We're pretending it's a long answer. And then negative 9.8 times 5 plus 33 meters per second. You're welcome. Okay, what's letter B asking? How high? How high? How would you fill this in? Find what? Find the max? The max what? Position. Good. As we're getting closer to the AP now, I mean, we're all year technically, but as we're looking forward to that more than we did last semester, you have to quantify, qualify what it is you're talking about. There could be a max velocity. There could be a max acceleration. We have to say max position, or else the AP guys are going to be like, you should have told me. I don't know what it means. And they're serious. So we have to say what we're talking about. But yeah, good. Find the max position. How do we do that? We could work backwards. We could go to position and then say, hey, I think he's a parabola, and let's find the max. But that would be a pre-cal way to go to position, which some physics people would do. Be like, oh, there's an equation for it, figure out the max. What's the calculus way? Instead of finding the max of the parabola, let's say what's going on at the maximum. We just talked about it. What's going on at the max? Changes direction, the velocity changes sign, and velocity equals 0. Booyah! That's something we can do. For the clue, we could say the max position is when? Think maximum, relative max, not v prime. I apologize. It's when x prime, or v equals 0. Why am I saying that? Because isn't it a lot easier than finding a parabola and finding his max? Can't I just set this equal to 0? Oh. Well, that's easy. Subtract 33, divide by 9.8, and we're done. So therefore, t equals, does it say when? Ooh, it doesn't say when. But get the t. 33 over 9.8 seconds. I'm not boxing it because that wasn't the question. What was the question? How high? But we need when. But now that we have the when, what are we going to do with it? Where are we going to plug it in? This one gets us a t. What are we going to do with that t if we need to find the max position? Plug it in. To who? Position. Ah! We don't have him yet. That's okay. How do we get position? Memorize a physics formula or just say, oh, he's going to be the integral of velocity. So how do we integrate negative 9.8 t? Yeah. Negative 9.8 t squared all over 2 plus 33 t plus, good, because it's starting from ground level, so my initial position, the c, is 0. So all I have to do is go ahead and, well, 9.8 divided by 2, that's a pretty common one in physics anyway, negative 4.9. T squared plus 33t might be a better way of writing that, but long story short, what do I need to do? Plug it in, plug it in. So x of, do you guys remember this test from last semester? You guys should not have simplified or tried to simplify because you didn't have your calculator and you guys were simplifying stuff all over and missing all the points on the motion problem on the test. Just plug it in. Negative 4.9, 33 over 9.8 squared plus 33 times 33 over 9.8. How am I going to label it? Feet. Yeah. Oh, I had to integrate. And so integrating, it's t squared over 2, and so the constant ended up being over 2. Yeah. Yeah. Are we good? Kinda? What's letter C saying? Pause. That was on the forever card last semester. How does speed and velocity relate? I forgot we'd already talked about this. Absolute value. Speedometer, there's no positive or negative. They're all positive. So find the speed. Find the absolute value of hits the ground. That sounds like a when, right? Find the absolute value of velocity when, well, wait, they said when. For, or maybe I should say at the t equals x of t sub 2 is equal to, does that make sense? Find the absolute value of velocity at or when the position is equal to 0. I just started doing like T1s and T2s to make it specific, but the long story short is find the absolute value of velocity, plugging in the time for which position is equal to 0. Right? Hit the ground? So what do I do with this nifty position function that we just solved for? Z equal to 0. So I can take my negative 4.9 t squared. Wait a minute, I can pull out a t. 0 is equal to, I need to use my hit the ground clue or else I have no idea what's going on. So here's my equation. 0 is equal to t times negative 4.9, t plus 33. Yeah, t plus 33. Why did I factor? It's the math. Yeah, I always have to, when I have zeros, factor and then set each one. I think, Christina, that's what you were saying, right? Does t equal 0 help me out? No, we already knew that. We knew it started at the ground and it's going to come back to the ground. How much time is it going to take approximately or exactly? Solve. Subtract 33, divide by 4.9, right? Divide by negative 4.9. So t is equal to 33 over 4.9 seconds. What do I do with that time? That's not what they were asking for. It's necessary. Plug it in where? Velocity. So the absolute value of velocity, 33.4.9. My velocity function is where? There it is. Negative 9.8 times 33 all over 4.9 plus 33. Now, you could theoretically put a big ol' absolute value and be like, ha-ha, I got it. Well, almost. We should put meters per second. Oh, I put feet. Ah, that would lose me points. Meters. I didn't read the problem. Lo siento. We could put big ol' absolute values around. But technically, just for sake of argument and seeing whether or not it's a negative that needs to switch or whether it's a positive that stays the same. 9.8 over 4.9 is just 2. 2 and 33 is 66. Negative 66 and 33 is 33, but negative. So I would make it positive in order to be speed. So this one I'll simplify just because it's pretty easy. But on a test, you just need to throw those absolute values around it, and you would be okay. My question isn't whether or not it's possible, because we just did it. It's possible, but whether or not you think you might be able to repeat it. Does that make sense? What are some things, like you guys strategize just for a little bit, because you're going to have homework tonight. You're going to be facing it on your own, not on your own. No one's alone. You have your groups. You have other people in the class. At least no one should be alone. But when you're facing it on your own, with like lifelines, but still you're supposed to be trying it on your own. What are some things that I did in this problem? Because I led it. I definitely led it. You guys helped. You supplemented, but I led. What are some things I thought about when I read a question? What was I doing? Looking at the important stuff, not just looking at it, but then trying to kind of like make it mathy, right? Like restate it, sort of. If I saw the word when, what was I saying? Find t. If I was seeing how high or how far or how low, what was I changing it? Find position. How fast would be find velocity. Exactly. When I was given something like acceleration, I was thinking, hey, I can integrate to get velocity. When I was doing things like plus c in integration, I was thinking like, hey, what's the initial? When I saw or thought of things like maximums, what was I always able to set something equal to? Velocity, good. Velocity equals 0. Velocity equals 0. Just because I had a question that said how high, was I afraid if I found a t from my clues? No, because what can I do with t? Plug into position. It's okay. You might not go straight there, but you'll eventually get there. Sometimes you just have to find like a time first and then plug in. All things to think about. Where are the mistakes that I made? Labeling the units. Did I make another one? I might have. That's the one I remember too. I might have made another one, but I forget what it was. Was there some math that could get a little complicated? But it's technically just algebra, right? So will you sometimes be needing to work with more than one equation, more than one unknown? The answer is yes. I'll tell you that. Yes, and you need to not be afraid of the math. Use substitution. You'll get there. How much was I simplifying? Not at all. But what do you do if you're trying to make sure you're right? Check in the back of the book. Sound good? Motion packet. Go find it. Because that's the end of our book examples. Homework due tomorrow. You had a motion homework last semester. Let's see if this one can go a little better. Because if you guys remember, you hated that homework last semester. Ugh. Like every single problem was a question. Let's see if we can do a little now. The concepts are a little bit broader because we have integration, but let's see what we can do. I think we never talked about number 11, but I think that was on purpose. We'll get back to it. Okay? We never talked about number 11, but it was on purpose. We'll get back to it. Let's go ahead and start playing around with some of these examples. This worksheet is not necessarily homework yet. This worksheet in its entirety is not necessarily homework yet, because we're going to be working on it in class today. We're going to be working on it in class tomorrow. You guys will sometimes have group work. Probably not today, because I'll help you get through as much as we can. We'll probably have some more group work tomorrow. Probably get you guys a little whiteboard so you can just kind of like hash things out and check answers with me before you write them down, et cetera, et cetera. But it might be homework eventually to finish it. So it might be something where you play with it a little bit if you finish homework early in the book, etc. But some of it, just to be honest, you can't do yet. Because we have not talked about graphs with area. So it won't be due this week for sure. Some of it we can do. Long story short, some of it we can't. We can definitely do number 1, though. Pause before you dare read number 1. You have to see what's been given. What's been given to you guys? You have a table of time and velocity for something moving along the x-axis. Pause. It always helps to get at least a little baby story in your head. There's a little particle. You can name him Bob. Bob's on the x-axis, and what is he doing? He's traveling right, left. He's a little point on an axis, just traveling. He's traveling right, left. How? I don't know. But I do know there was a picture taken of him when time equaled 0 seconds, and he was at this position. He was at the -3 tick mark. There was a picture taken at 2, after 2 seconds, and he was here. Now, do I know what he did? No. He might have gone straight there. He might have gone backwards and forwards. He might have been like, boing, 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 boing. Like, I don't know. But he was there, 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 he was there at these times. That's all I know. I have no idea what else he was doing in between that, besides the fact that he always had a rate. He was never, like, time warped into a different dimension. AKA differentiable function. He was there and he was moving the whole time. He could have been stopped, I suppose. At t equals 0, is the particle moving to the right or to the left? Pause. Was he at the -3 tick mark at 0? It's not where he was. At 0, what's the -3 represent again? How fast he was going. I don't even know where he is. Nope, no clue where he is. Never mind, I don't know where he is. At 0, I know how fast he was going. It's little pictures of his speedometer, if his speedometer went positive or negative. Okay, what do you guys think? Moving to the left or to the right? If -3 is his velocity. Good. Why? Bob the particle. Don't just say negative. I know what you mean, but the AP graders wouldn't take it. You have to have a very detailed, not definition per se, argument to your answer. So the particle is moving left. Christina, you're saying it. Why? Don't say it. Don't say it. The velocity. Good. The particle is moving to the left since v of 0. You could do it like that. Or you could put it in words, since the velocity or velocity at t equals 0 is equal to -3, which is less than 0, which is negative. Different ways of saying it. But long story short, his velocity is negative at 0. There, particle's moving left. Done. Number 2. function is differentiable. Velocity is differentiable according to the givens, which means velocity is continuous. Acceleration is continuous, which probably means position is continuous. They're asking me, is there a time during the time interval when the particle is at rest? Look at the table first and say, were there any snapshots that showed his speedometer at 0? No. None of them. So I don't know. No, you do. I heard someone say yes. Why are you right? There's a change in direction. If there's a change in direction, where must that change of direction occur? At a 0 of velocity. Why did they not ask me for the time? Because I don't know the time. But they asked me, is there a time? And the answer is yes. The particle must stop. Tell me a time interval between 0 and 2. It must stop at least there. Must. Between 0 and 2 seconds. I think it's seconds. Oh, minutes. Ah! Lo siento. You could even put it in words and say something like somewhere within the first 2 minutes. You can actually use the words. You don't have to use the math. Somewhere within the first 2 minutes or somewhere between t is 0 to 2. Struggle. What does it say? Explain. Ah, since. All right. You have to have a mathematical argument to back up your claim for them to give you full points. Since. The signs of velocity change? You're right. But what theorem from that, there you go. Since velocity is continuous, isn't that a given for IVT? The function must be continuous. Since velocity is continuous and changes sign on that interval, the particle must stop at least once between t equals 0 to 2 minutes or somewhere within the first 2 minutes. Since velocity is continuous and changes sign on that interval. My grammarian self is not liking this. I'm about to say which. But that'd be a secondary comma. We'll just say by. There you go. We can say by IVT. You can write out intermediate value theorem if you really want to, but IVT is sufficient. IVT is good. MVT is good. EVT, I've never actually seen you need to use it on a free response. It's always like in thinking about a multiple choice. IVT, MVT, FTC. But we haven't learned that one yet. Okay. Use data from the table. You could also say something to the effect of, since IVT applies, and then you could say because. You could put in a few different words like that. You could kind of flesh it out a little bit better, but that's sufficient. Number 3, use the data from the table to find an approximation for v prime of 10. Approximate a derivative and explain the meaning of v prime of 10 in terms of the motion of the particle. Show the computations that lead to your answer and indicate units of measure. This is a very typical AP-ish wording of a question. Do some sort of mathy thing. Talk about what you just did and what it actually means, and then make sure you put your units. Guys, v prime, look at your table. V prime of 10. How on earth are we supposed to figure out v prime? These are v's. Oh, no one's saying anything. V prime is a slope of a tangent line. Is a slope, right? Do I know any v primes? No. But can I play with slopes given points? Yes. It's called average versus instantaneous. Average approximates instantaneous. What's the formula for an average rate of change of something? Now, S of B minus S of A over B, change in S over change in T. That would be ds dt. That would be velocity. I don't want that. I want change in V over change in T. That would be average acceleration or average rate of change of velocity. So what do you guys see if I'm talking about when T equals 10? Thinking about how we have to do f of b minus f of a over b minus a using the function of velocity. Oh, come on. If I say t equals 10, what are you seeing? Just tell me what you're seeing. You're seeing 8 and 12. You're not seeing 10, right? Wait, you're seeing 8 and 12. How many points is that? 2. So use the 2. They're not going to tell you exactly what to do, but they're going to give you a location. V prime of 10 is going to be best approximated using the average rate of velocity over, we don't have 10. Okay, cool. Then use 8 to 12. And this is more for you to understand what I'm about to do. A derivative is a slope. A slope, I need f of b minus f of a over b minus a of my velocity function. And the ones I have around 10 are 8 and 12. All right, cool. Let's do it then. I have my little approximate sign because it's not going to be exact. But we can do v of 12 minus v of 8. All over 12 minus 8. You guys have your table in front of you. What is v of 12? 5. What is v of 8? 7? I'm not going to get this wrong. I'm not going to simplify that, even though I should be able to do that, but that's okay. What are my units? Feet per minute? Meters per minute? Meters? Wait, why am I going to put minutes squared? That was a meters per minute, and that's a minute. Does that make sense? If you want to, you could totally do meters per minute. Per minute. You're not wrong. Right? Those are times. Those are velocities. That is your v prime of 10 approximation, but they also say to explain. So it's completely up to you. But I, in my head, am going to realize that 5 minus 7 is a negative number over a positive number. I'm going to realize this is a negative quantity. So I'm going to say something to the effect of velocity seems to be decreasing at t equals 10 minutes. According to the approximation found above. That's one way. Or I could say something to the effect of the velocity is changing at a rate of, what I can't do is put in the word rate and put in the word decreasing, because decreasing, increasing already points us to a derivative, right? So if I say rate and I say increasing, decreasing, I've just made a mistake because in my wording, I've talked about a second derivative. The first derivative of velocity. So using velocity, I can either use the word decreasing because I saw it's negative, it meaning the approximation for v prime, or I could say velocity's rate of change, or is changing at a rate of, but I can't use both. And specifically, isn't this about Bob on the x-axis? So I could talk about my particle on the x-axis too and talk about how he's moving horizontally and his velocity seems to be decreasing. But the long story short, velocity decreasing at 10 minutes. What's number 4 talking about? Acceleration? Who's acceleration? compared to velocity, who are the guys that I have in my table? The derivatives. So wait a minute, what if I was to rewrite this and say v prime of c equals 0? Isn't there a theorem that says there must exist a times c in the interval 0 to 12? Technically it's open, but that's okay. Such that the derivative equals 0. What's going on? What theorem is that guarantees a derivative value? It's not IVT. IVT is the actual quantity. IVT is velocities. That was letter B. Who talks about derivatives? MVT. MVT. And what specially is happening on MVT to make it equal 0? Well, go ahead and write it and say, okay, well, according to MVT, can we just start doing MVT? Since velocity is continuous and differentiable on 0 to 12, on 0 to 12, then there must exist a t within 0 to 12, which is in this interval, so it's okay, by MVT such that, are I just stating MVT for this velocity and these like times? V prime of t, which we know is acceleration, equals v of b minus v of a all over b minus a. Hold on, I need this to equal 0. How could this possibly be 0? What's going to happen to these two guys? Are there any places where the velocities are the same? Ha! Yes. So what am I going to say? Since v of 6 equals 5 equals v of 12. I'm going to go back and I'm going to change it from 6 to 12, which will be on the interval 0 to 12, and I'll be good. Whew. We got through a good packet example. You guys are working on your book tonight, submitting it in Google Classroom by tomorrow, maybe using the PDF app. See you guys later. Alligators. Happy Wednesday. There are plenty of donut holes if you want to grab one on the way out, or 2 or 10.